Hey guys, welcome to 10.2. Today we're continuing to talk about solutions by talking about something that's very important to solutions, concentration. So there's a lot of different ways we can look at concentration. Today, here on day one of 10.2, we're going to focus on molarity. Now, before we get into that, here is a slide that kind of reviews the terms solution, colloid, and suspension. So, what I want you to do is I want you to read these three bullet points, 1, 2, and 3 here, and then tell me which one of these describes a solution, a colloid, or a suspension. Go ahead and pause the video, answer these questions, and then play it when you're ready to go. Okay, so let's go over these three questions. It says, Nivag Yor dares his friends Yog Orig to drink three different mixtures. For the first one, when shaken, it appears uniform, but then settles out later. That is typical of a suspension. For question number 2 here, it looks transparent but has a salty taste. That is typical of a solution. And number 3, scatters light due to the Tyndall effect. That is a colloid. So, shaken out but appears uniform. Remember, that's a property of suspension. If it's transparent, but it doesn't taste like it's not just pure water, that would be a solution. And then for number 3, Tyndall effect is a property of colloids. Remember, that's light scatters when it hits a colloid. Great. So hopefully you're feeling comfortable about suspension solutions and colloids. If not, look back at the notes for 10.1. So today what we're going to be talking about is we're talking about this thing called molarity. And molarity is a type of concentration. So when we're talking about concentrations, we're mostly talking about solutions. And we're specifically talking about the amount of stuff inside a solution. So usually you have your wet part and your dry part. You've got your solute and you've got your solvent. Molarity looks at the ratio between solute and solvent. If we have a lot of solute in our solution, we call that concentrated. So think about it as like really salty salt water would be concentrated versus not so salty salt water would be dilute. So those are two terms we have for you, dilute and concentrated. It's not really important that you know like a great definition of them. So I just have dilute is watery and concentrated is salty. That's the definitions I'm rolling with. That's about the level of complexity we're getting with those. Now, when we're talking about molarity, we have specific units. The units are moles per liter. So that's worth writing down. Molarity stands for big capital M, and that equals moles per liter. Those are the units for molarity, and it's also going to be how you solve molarity-related problems. You're going to need to know your moles of solute, and you're going to need to know how many liters of solution you have. And down here is an example saying that a 6 molar solution of HCl has 6 moles of HCl for every 1 liter. So if you do the math, if you look at the periodic table, 6 moles of hydrogen HCl, that gives you 217 grams of HCl per every liter. So that's pretty concentrated. Honestly, guys, this is fairly straightforward. The difficult part is going to be remembering, hey, how do we convert from grams to moles? So you're definitely going to want to have your periodic tables out. You're definitely going to want to have your calculators out. And you might want to even look back at the notes from 6B, where we talked about molar conversions. So here's the formula. This is definitely something that you're going to want to take a look at. Molarity is going to equal moles of solute over liters of solution. Now, usually when we're writing out the formula, we don't write all of this. Usually, sometimes we can simplify it to M, big capital M equals moles divided by liters, or we can even simplify that further to big capital M equals MOL divided by L. Now, it's important to remember, though, if we are using this final equation here, big capital M equals mole over liters, that we do remember it's moles of solute divided by liters of solution. That's going to be important to remember kind of what are we looking at, what are we finding moles of, what are we finding liters of. Here's a screen of a Kool-Aid man because our next example we're going to talk about here is we're going to be talking about Kool-Aid. So if you look at the back of a Kool-Aid packet, which who does, it says to use 1 cup of Kool-Aid mix, which is pretty much sugar, for every 2 quarts. And you'll see that I've converted those into grams and liters respectively, so you didn't have to. Now, what we want to find in this problem is we want to find out what's the molarity of sugar in Kool-Aid. So that's the problem. Now, how we do that is we have to first figure out what's the molar mass of sugar. I just gave that to you. If you were looking for this, you would just use a periodic table, figure you have 12 carbons, multiply that by carbon's molar mass, 12.01, 22 hydrogens, multiply that by hydrogen's molar mass, 11 oxygens, so on and so forth. You get 342.34 grams per mole. So in order to figure out the molarity of sugar, we have to figure out how many moles of sugar we have. So what we're going to do is we're going to take this 220 grams of sugar and we're going to convert that into moles using this 342.34 number. So when we do that, we're going to get a value, I think it's 0.6423 moles. And then we're going to divide that by our total number of liters because molarity is just moles divided by liters. So that's where we get the 1.893 liters. And then you get a molarity, big capital M, of 0.339. And then the units here, you'll notice it's moles divided by liters. You could also just use the unit big capital M. Big capital M could just be your units there. That works. You don't have to always write out moles divided by liters like I did here. Hopefully this makes sense. In terms of the math, it's just a conversion and you're dividing moles by liters. Not a whole lot of difficulty here. The important thing here is just to remember, I think it's fairly straightforward. So just remember the formula pretty much and you should be okay. Here's another problem. Why don't you guys go ahead and try this out on your own. Here now, instead of giving you grams or moles, we give you molarity, and we also give you liters. So go ahead and try this problem out. Okay, so hopefully you had enough time to do the problem. Let's go ahead and take a look at the solution now. So in this question, what's different, hopefully you'll notice, is that we give you molarity and liters. Instead of just giving you moles and liters. So if you're looking at the equation, big capital M equals moles divided by liters. Here what's missing is the blue part, the moles. So that's what we're going to solve for. In order to do that, first let's kind of plug in what we have. We know we've got molarity and we've got liters, and we're looking for grams of sugar. So once we get that value in moles, we're going to have to convert into grams of sugar. Hopefully you can see here, just below the problem, again, there's that molar mass of sugar, so you don't have to find it on the periodic table. Tried to save you a little bit of work there. Okay, so I've laid out big capital M in purple and liters in green. So in order to solve this problem, you're going to want to isolate that mole variable. So we're going to move liters over, and then we're going to multiply these two numbers. When we do that, we get 11.07 moles as our blue mole value. Once again, in order to convert that into grams of sugar, we're going to have to do a molar conversion. So we use that 11.07 moles, put moles on the bottom, grams on the top. So you're going to multiply 11 by this 342 number, and you get about 3,791 grams. Correct sig figs here should be 3,790 grams. In case you were wondering, if you do convert that back into cups, you don't have to do this for the problem, but this is more just a fun fact. If you convert this into cups, you get 17.2 cups of sugar. So in 2 quarts, you can fit 17.2 grams of sugar, and that's called having it saturated. So that's the maximum amount of sugar you can fit into 2 quarts, which is pretty crazy. At that point in time, the solution wouldn't really look like a sugar water solution or a Kool-Aid. It would kind of look more like a syrup. So that'd be kind of gross to drink, but Yeah, fun fact. Here with the next slide, I'm just really showing you two different concentrations of HCl. We've got a 1 molar versus a 0.1 molar, and just going through the math and showing you that if you have a 1 molar solution, that gives you 36 grams of HCl. So you've got 36 grams of HCl dissolved in 1 liter. If you compare that to a 0.1 molar solution, you can probably guess that you'll have significantly less grams of HCl, and you have 1/10 the amount. You have 3.6 grams of HCl here instead. So this kind of just goes to show you that a 0.1 molar solution has a lot less solute in it than a 1 molar solution does. Yeah, that's about it. Hopefully you guys had a great time with this. Hopefully this all makes more sense. Thanks for watching, and have a great rest of your day.